Welcome to this logistics webinar. My name is Claus Haselmeier, and in the next minutes, I would like to give you an idea and the confidence that LVM Vision can be the right partner for your camera application in the field of logistic vehicles and warehouse automation. Logistic applications have quite different requirements in their respective fields, so I would like to start right away with application examples for AGVs, AMRs, and forklifts. The use cases for AGVs, AMRs, and forklifts are, let's start on the left side, barcode and QR code reading for parcels or to determine the position of vehicles on the ground. Shape detection in 2D and 3D of pallets or packages. Pothole detection on forklifts to avoid accidents. Collision avoidance with people or with other vehicles. Or an automatic inventory control of goods. Also, this becomes more and more interesting in regards to digital twins. Recognition of high-res storage by their shape, position, or OCR. Let's continue with the application examples for the field of robotics and conveyor technology. Of course, also here the number one application is reading the barcode and QR code, but also bin picking of components with stereo cameras, position detection of components or packages to transfer the coordinates to the robot, or sorting goods on the conveyor belts with 2D or 3D, classification and the counting of objects on the robot or conveyor. Now let's take a closer look at the requirements of conveyor belts. Depending on your application, the requirements of the field of view are quite different. We can support with different resolutions from 0.5 to 25 megapixel depending on your field of view. Furthermore, a requirement can be the volume and shape measurement in the throughput of packages. This is not entirely trivial, but up to 60 frames per second possible. Due to sometimes very high speeds of the conveyor technology, also very high frames are also required. Here especially flow controls and also the appropriate interface enables very high data throughput. If you require short latency and a lean overhead of your embedded system, MIPI CSI2 is often the first choice. Since you are here sometimes limited with cable lengths, we also have our all-new FPD-Link and GMSL2 with up to 50-meter cable lengths. However, this protocol is not driver compliant. We have developed for you the drivers for the NVIDIA Jetson family, the NXP i.MX8 and the Xilinx Sync in Clear. And these are all open source and available on GitHub and supporting you to a much faster and cost-saving time to market. Let's continue with some requirements for logistic vehicles. Small sizes are required for space constraints and weight limitations on those vehicles. We can support here with the sugar cube design and barebot cameras. Long cables for multi-camera solutions or greater distances between the camera and the embedded host is often needed. High frames per second and data throughput for high-speed applications are supported with MIPI CSI2 protocol. When using MIPI CSI2, we support you with a faster go-to-market with a full-featured open-source driver set for MIPI CSI2 and our all-new FPD-Link 3 and GMSL2 cameras. CSI2 and the range extender like FPD-Link 3 and GMSL2 are the first choice for requirements with low latency and a lean system overhead for your safety-relevant application. Often, real-time 3D depth information are needed for navigation and collision avoidance. I think you could see that we're quite familiar with your requirements in logistic applications. For this, we have developed a platform that it uses very different transmission technologies, the Alvium platform. It has an integrated ISP on our own developed ASIC. This means that you only need a single driver for MIPI Z2 cameras and our range extenders, with an extensive selection of 30 different sensors. Furthermore, a very extensive camera feature set, such as a convolution filter or different auto modes that support your application. Different lens mounts like S mount or C mount and different housing options are available. This brings us to our different interfaces and our product overview. Here's an overview of our Alvium 2D cameras, which are all built on the same platform. Here you can see the red housing, and the black part is the respective backend with the different interfaces and protocols. Also, on the right lower corner, you see our 3D Ruby, which has a gigabit Ethernet interface. LED Vision is part of the TKH group. Under this, the TKH Vision Solution Center was founded. You've already probably seen the TKH Vision Solution Center logo in the application examples. This was founded to combine the technologies of LED Vision and his sister companies to develop customer-specific solutions that are precisely tailored to your requirements. From the camera and sensor component to the solution. Strikingly, an edge cam or smart cam that is manufactured accordingly to customer requirements. This, for example, could include the right camera and interface protocol, an IP67 housing, and embedded board like, for instance, NVIDIA Jetson NX. And of course also the right application software, for example, reading barcodes or object detection to avoid collisions on forklifts. Thank you for your attention. LED Vision operates globally, but also has its production at its home base in Germany. I look forward to learn more about your requirements in logistics.